It's one thing to convert a position time graph to a velocity time graph. It's another thing entirely to only be given a velocity time graph and be able to use that to make inferences about the motion of the object. So that's what we're going to look at in this video. Here we have a very simple velocity time graph. This was an object that was moving at 4 meters per second for 8 seconds. That's it. Didn't speed up, didn't slow down, just for 8 seconds it moved at 4 meters per second. That's what is represented in this graph. Now, one of the things that we should take a look at is that we have essentially a rectangle here. So the slope is 0 because it's just a flat line. Now we know that slope has meaning, but there's something else that has meaning as well. And if we recognize that this this rectangle is here, the rectangle has two sides. One side is 8 seconds, and the other side is positive 4 meters per second. Right? One side is the time, the other side is the velocity. It's a velocity time graph. If we calculate that area, or what we call the area under the curve, we can actually get a value. So let's do that now and just try and figure out what that value means. So since this is a rectangle, we can essentially take the length and multiply it by the width. Essentially, in this case, it being 8 seconds times positive 4 meters per second. And if we use our kind of mathematical skills, we recognize that seconds on the top and seconds on the bottom should cancel out. And that leaves me, when I multiply this, with a final answer of positive 32 meters. Now, 32 meters plus a direction, hopefully that screams out to you that that quantity right there is a displacement. So positive 32 meters is a displacement. So the next thing we have to make sure we add in our toolbox of analyzing these graphs is that the area under a velocity time graph, meaning the area between the graph itself and the x-axis, the area under that graph for a velocity time graph is the displacement of the object. So just like the slope of a position time is the velocity of the object, the area under a velocity time graph is the position or the displacement of the object. One of the ways I like to remember this is with this little kind of infographic that I came up with a little while ago, and I kind of remember it this way. The very first thing we ever learned about was displacement. So I just write delta x for our displacement. After displacement, the next topic we discussed was the velocity. So then I write velocity. So from the top down, we learned about displacement, then we learned about velocity. You're essentially just listing out the order we learned things in. You then draw these two arrows, these kind of counterclockwise arrows on each side. So the left side is going down, the right side is going up. And then from left to right, you write what we learned about in terms of analyzing graphs. So the first thing we learned about was the slope when we started to analyze position time graphs. And then after that, on the right, we learned about area, which we just learned about today, or in this video, as a matter of fact. So if you can remember this and draw this out, the way you look at this is you take a look at what you're given. So if you're given a position time graph, then you're really given the displacement. And if you want to find velocity from that, well, the arrow that goes from the displacement time graph to the velocity time graph, or the position time graph to the velocity time graph, is slope. If you're given a velocity time graph, you start with v because you're given a velocity time graph. To get to the displacement, you have to look at the area. So you don't have to memorize this, but if you do, it's a nice, quick, easy way to kind of figure out, well, if I have this type of graph and I want this, well, let me just follow the arrow. Oh, find area. Oh, find slope. All right, let's use this in a few examples in the coming videos and put it to practice.